Okay, so now we're gonna just go through an example. I just made like a new PCB dock to show you, but you'll just open up your clock tower board and it'll just show you like this blank screen essentially. The origin might be elsewhere, it might be a different size, but this is what it's gonna look like when you it's gonna look like just like a blank board. And you can look at that in 3D if you want. It just is a blank, it's just blank. So that's all you're gonna see when you first open this up. The very first thing you're gonna do after you fix your schematic, so we've done our schematic reviews together, you fix your schematic, make sure it's correct. You're gonna go in design, import changes. This is going to show you all of the components to be added and all of the connections that are going to be added between them, and um, etc. One thing that you're going to see if you scroll down to the very bottom of this is this add rooms function. I will show you what that means. Basically, what that means is that every schematic page has a room, and all the components need to go inside that room. And you can't put components outside of the room, and you can't put components from other pages inside of the room. So I usually turn this off because I think it's obnoxious. I'll just show you what it looks like. You can just execute all these changes. You can validate first if you want. It's gonna be fine. And what that's gonna do is gonna create this big room. And basically, if you try to like move a component outside of that room, it's gonna be an error. You can do it, but then like once you see how it's like green, for some reason in Altium green means error. And you see those problems. You're like, what's wrong? It's because you just moved it outside of the room. Rooms are stupid. We're gonna delete that. Another way that you can get rid of this is you can go to project options and you can go to class generation, and then you can turn off generate rooms for your different schematic sheets. I would do that if I were you before you even import these components. Just turn that off. It's obnoxious. That's all. So the first thing you're gonna do is you're gonna, put all your components on. You're gonna like put them roughly where you think they should go. You can put them wherever you want. And once you have like a general idea of how big this board needs to be, then you can go about defining the actual shape of it. So the way you're gonna do that is by doing place line PL. Probably gonna do this on a mechanical layer. Place line, and you're gonna go through and just make like a little shape. I'm just gonna do something kind of random, but you can make this look kind of nice. This is not like even. Make this better. I'm just going quickly. There. So now I have the shape. It's kind of ugly, but I did it. And you'll highlight this, and you can go to design, board shape, define from selected objects. Now you have a roughly clock tower shaped board. Again, make it better. This is ugly. And you notice your origin is like, this is your origin. This is like defining where your origin is, this little white thing here. So you can change that by clicking EOS, and that will set your origin to wherever you click. So I just go to the bottom left corner and say, this is my origin now. And that way, like this little thing up here will show you where you are. So this is like 0, 0. And you can move to different points, and it'll tell you like where you are relatively. Another helpful thing, I think I mentioned this in the component making, but you can press the button Q, and that will switch you to metric units, so you can switch back to freedom units, Q, millimeters and mils. Usually I place components in millimeters, and then I place traces in mils, because that's like what manufacturers are going to base their like dimensions off of, but it doesn't really matter. You can do whatever you want. One thing we talked about earlier is the grid. So if you press G, you can see what kind of grid you want to use. You can do it either in millimeters or mils. You can have like a pretty big grid, and that will mean you can only place things, on here, or you can have a pretty small grid, again G, and it's a lot more granularity. So that's how you change your grid, and things will snap to the grid. It doesn't matter as much for this component again because it's kind of just like a fun toy, but more useful for when you're making more intense projects. So yeah, you can like place things around. This you can see this thing I was talking about earlier. This like rat's nest will show you like what things are connected to what. It will create little lines between them, just like the shortest path between them. So that's basically how it's going to go. You can place all these things. I made it like a little nice like face where there's like a piezo buzzer in the middle, and all the LEDs are surrounding it. So when you place a clock tower, it looks like a clock tower. You can do that if you want. You can, if you are having trouble like placing these components while looking at this big nest, you can press NHA, and that will hide all of them, or you can press NSA to bring them back. You can also do this with you can also like hide certain nets. So if you see you want to hide ground, because you're going to have a ground plane, so you don't need to see that right now. You can hide ground, you can hide VDB, and that will make it just like a little bit cleaner. Again, bring them all back, NSA, NHA. I find that a little easier to do when I'm first placing components, but you might want to look at them so you can see like how close should I place things relative to how related they are. So you can do that. I'm gonna put these back on so I can show you guys how to make traces. So what you're gonna do is, if you want to connect two things, this is in no way, shape, or form how you should be connecting these particular components, but I'm showing you how to do it. So if you want to connect VDD and VDD, you can press place PT, and that's place trace. And you can either be on the top or the bottom layer. If you want to switch, you can just click on here, and you can place trace VDD to VDD, and that will connect those two components. As you can see, the line between them went away because now they're connected. It will not allow you to connect things that are not supposed to be connected. Like you cannot try to connect these two separate things. As you can see, it's not letting me do it. It's like, no, I don't want to. You also cannot cross a different line. You can't cross these because these will short them. So if you're trying to like, oh, I want to just go through here, it's not going to let you. That's not allowed because that would short these two things. So if you want to cross it, you can place a via on that, and you can switch to the bottom layer and place another trace, and you can go on the bottom layer and route through it because these are different layers, like I mentioned in the video. That's how you will get around things. And again, doing this at right angles is super useful for like crossing things and not trying to like have a huge mess. You can change the dimensions of this via. So right now I'm in millimeters, which is stupid. Let's see. If you click on this via, it'll tell you like it's a 10 mil via, which is totally fine. Yeah, because these are 10 mil traces. So you want them to be like I said, like the diameter should be the same, so it's not like a pinch point. Let's see what else. So yeah, you're gonna have to place all your components. Make sure your decoupling capacitors are very close to the things that they're decoupling. So you'll have your VDD and your AVCC pins, and those should both have decoupling capacitors right next to them. The way that you're going to write a decoupling capacitor, let's just grab one so I can show you. Is it one of these? Let's see. No. Just trying to find a decoupling capacitor to show you guys how to route them. Basically, you want to make sure that the signal is going through. Here we go. C2. Okay. You want to make sure that the signal is going through the capacitor and not around it. So you'll place a capacitor. You can again rotate with the spacebar. And what you can do is you can make sure that the trace from VDD is going. Oh, that's the wrong side. Is going through this capacitor, and then you can connect it to maybe you have a power plane. You can connect it to that with a via, and that will just via down to the plane, and then you're connected. What you should not do is this, where you via down from the plane. Let's see. And then you place a via. This is what you should not do, because what this will do is it'll pull up from the plane. It will go to the power point, and then it will go to this filter. This is not doing anything. This is not helpful. Don't do this. It's not actually decoupling anything. It's sending a signal right here, and then the signal is going here. Not useful. Don't do that. So yeah, make sure it goes through the capacitor before it goes to the component. How do you actually make power planes? Great question. So what you can do is you can go to, I believe it's Tools, Polygon Manager, and you can create a new polygon from the board outline, or from if you want to like draw a square and like have like a little polygon, you can do that instead. So you can do from a selected polygon, but you can do the whole board for a ground port or something like that. So the net, you want to make sure it's connected to the right net, so it'll be connected to ground. Of the top layer, this is the stuff with like removing islands. So if there's like a little square that's like not actually connected to anything, it'll remove that. And then you can remove dead copper, which means if it's not connected to anything, just remove it because it's not actually doing anything. It's just basically creating like a copper tab that's not connected to anything, which can be a problem for antennas and capacitance and etc. So you can just remove dead copper if you want. Make sure you're pouring over only the same net. And basically that will port over, that will connect it to any point that should be connected to it. So you can report this, and it should create a port over the whole thing. As you can see, this ports over the entire board, and it will connect to only the points that you want to connect to. So if you close this, you can see that is that thermal relief I was talking about. So you can see ground is connected to the ground plane. Ground is connected to the ground plane. VDD is not connected to the ground plane. That is what we want. So yeah, they'll just be this like thermal relief in the sense that it's not gonna be directly connected to the big plane. You just kind of either way, it's probably not gonna matter. You're hand soldering this, so don't really worry about it. That's kind of what I was saying when I was saying like it was pretty hard to look at this, and also if you pour this and then you try to make traces, it's going to like uh, cause problems. You can't really see it because you need to repour it. So you can either constantly repour it by pressing TGA and that will repour, or you can do is what I do. I just hide these while I'm working. I say TG H and that will shelve it and it will go away, and then it's still there. Like you can still use it. You can bring it back with TGE. You have to report with TGA. I just like to hide them because I think it's pretty hard to look at personally. Whatever floats your boat. That's how you make a polygon, and then anything you make, anything that you create will be connected to that. And then you can do the same thing on the other side. You can say, okay, the opposite side, I'm going to make a. You can again go to the polygon manager and make another one that's on the power plane. So you can say, okay, this one's connected to VDD, and I'm gonna put that on the bottom layer. And you could do that. That's gonna create a bottom layer, and then you can connect VDD to all of that. So yeah, you do that if you want. Let's see what else. Silk screen. So these are gonna be on the silk screen. If you look at it in 3D, first of all, it's kind of nice. You can see like the components. You can see what things look like. This is a switch. This is the buzzer. This is the battery. This is the MCU dip holder. You can see that there are these okay, these like designators. This one's kind of hidden, so you need to move that. You can basically just drag it out of the way. You can also resize this. What I like to do is select all of them and resize them. So I like to say right click on it, find similar objects. Also a designator. So I like to say if it's a designator, find it. That will select every single designator, and then you can change the size of them. So I like to make them smaller because I think they don't need to be that big. So I make them 30 mil by 6 mil, and this just like resizes what they look like. So it just makes them like a little smaller and kind of out of the way, which I like because they're kind of just for reference. You can also add other things to the silk screen. You can say, okay, it's on a layer called top overlay. If we isolate this, you can see all the things that are written on the board. Again, that's Shift S, same thing as components. And what you can use, you can place text, PT. Oh no, sorry, that's trace. Place string, I believe it is. Yeah, string. So PS, and then you can write things. You can say like this is like the on part of the switch. You can say this is on, and then you can put off here. That's one thing you can do with silk screen. You can also like write your name on it. I would highly suggest you guys write your name on these boards because if we're going to be making them for you guys, I want to know who's who when I pass them out. So you can just be like, I'm Katie Bradford, and this is my board. You can see from the boards that I gave you guys, I wrote ECEs can do everything, and then I also made some fun little like clock tower decorations. I wrote like the time in Roman numerals, so it looks more like a clock tower, and I made it look a little bit like dingly dingly, just for fun. You can do whatever you want. This is your free reign. Yeah, so that's the basics of things. You can, yeah. This is going to be kind of a lot. This is going to be a little difficult if you've never done this before. There's a lot of information to consume. Take your time with it. If you come to the design review and it's not very good, it's okay. Like my first design review was absolute like garbage fire. It's okay. Just like try your best. Listen to things that I told you in the video, and hopefully it will be okay. Again, run design rule check as frequently as you want. So you can say tools design rule check. You can run it. If you don't repour your polygons, it will probably give you errors if things are not connected. So do the TGE thing before. It's gonna be tons of like unrouted net constraints, which basically means I haven't actually connected all my nets yet. So that's gonna be a problem. They're not actually connected, which is correct. Soak to solder mask clearance. So this means this is because all the components are just like off the board right now. And then net antenna. What that means is that I made this. It'll show you. It'll have a look at antenna symbol. What this means is that see this little antenna. This is what that means. That this is not connected to anything. So what this is just a wire, and that acts as an antenna. If you've seen an antenna, it's just like a metal wire. That's what this is. This is an antenna. So that's gonna be a problem. So that'll tell you how many errors you have. When you're done with this, this should have no errors. Modified polygon, again, this is just the fact that they're shelved right now. So that's what that problem is. So run this frequently and just see if you're doing anything wrong. These are going to give me all these errors about like unrouted net constraints. because I haven't routed them yet. You can just tools, reset error markers, and get rid of all the errors because you'll fix them. If you want to change your rules, you can go to design rules, and then you can look at all different kinds of things like hole sizes and clearance rules. So how far can a track be from a track? How far can text be from a track? How far can a via be from copper, etc. So you can change all of those things. You can ignore them within a footprint. So the footprint is the thing you guys made. It's like if your paths are really close together on a footprint, you can ignore that for like a clearance constraint if you want. You can dig through these. There's tons and tons and tons and tons of rules. Play around with these, see what you like. Yeah, we'll be manufacturing these through JLC PCBs if you want to look at like their constraints. You can check that out. And that's all I'm going to say for now. Post in the if you have any questions. We'll do design reviews again next weekend, and probably a little bit after that because this might take a little while. But yeah, that's the plan for this week. So best of luck with this.